Where's the problem? At 0 again, down on the bottom. So take your calculators. Was it 1 over x cubed?
Yep.
So x to the negative 3?
Negative 1/3.
No,
Yeah.
negative 3. You should be suspicious.
Oh, not no.
Tolerance.
Nope.
Okay, so it's telling us that it can't get this problem to work out with those limits of integration. So let's see what happens when we do it using the definitions. So this becomes the limit as a approaches 0 from the right of the integral from a to 2 of x to the negative 3 dx. So that's the limit as a approaches 0 from the right.
So it's 2
X to the negative 2 over negative 2 from a to 2. So let's clean that up a little bit.
1 over 2x squared.
So negative
1 over
1 over 2x. Yeah, that's much nicer to look at. A to 2. Fundamental theorem. Plug in the top number. So that's negative 1 over 2 times 2 squared minus negative 1 over 2 times a squared. So negative 1/8, good.
Plus
0. 1 over 0.
which is 0.
Lordy Pete, no, 1 over 0 isn't 0. What's 1 over 100? Let's go the other way. What's 1 over
It's infinity.
1/10?
It's
10.
infinity.
1 over 1/100th? 100. 1 over 1/1000th. So the smaller I make this,
It's infinity.
the bigger that fraction becomes.
So is it infinity?
So it's infinity plus 1. I don't know how you write that.
What's infinity?
Just infinity.
That's infinity. Let's go back. Let's go back to Bill Gates. If somebody asks him how much money he has, he says infinite. Even though he may have deposited a check for $500,000, he's still going to tell you he's infinitely wealthy. Adding an eighth or subtracting an eighth to infinity is inconsequential. But this isn't the answer. What you write is diverges. No, diverges. If it goes to positive infinity or negative infinity, the answer is diverges. I've seen the calculator give answers to ones that diverge, and I've seen it give that tolerance thing to the ones that diverge. So I say use it wisely on your homework. Yeah.
So if it's the limit as a number for x approaches 0, and it ends up being a number over 0, it's infinity?
Yeah.
Okay.
It's like 1 over x. Or no?
Yeah.
The bottom part keeps.
The bottom, yeah, look at 1 over x. This is actually 1 over x squared. And 1 over x squared looks like this. But as you approach, that 1 over x squared is getting bigger and bigger and bigger and bigger. Grows without bound. And the other one one, which is the constant over, I forgot where I was going, sorry.
Constant over zero?
I don't know, I don't know
Probably
where my
approaching infinity
brain
at the
went,
bottom,
but it's
and then
okay.
it
Well, we had zero, we had a constant over zero, which
No,
was
we had a
infinity, so
constant
zero
over
or
x to a
constant.
power. We had a constant over x to a power,
Which is
and that goes to zero. That thing goes to zero.
So what's x to a power over a constant?
Because this one was x was going to infinity at the beginning of class.
Yeah,
Well, you said that one was zero, or infinity.
when it
No, I
approaches
didn't. I
infinity,
said
it's
this one
going
goes
down.
to zero.
But when it approaches
Look-
zero,
look at-
it
look
goes
at
to
this curve.
infinity.
That
Oh,
was,
as-
that
oh,
was
as it approaches
earlier.
infinity.
But right
Yeah.
now, we're
Yeah.
going to
Yeah.
zero,
Yeah.
and that, your
Approaches
finger's going up. So
infinity.
you're just gonna have to look and see, where is my finger going?
Mhm.
Is it going to zero? Or is it going to infinity? Okay, that was where I was going, because I wanted to make sure I got those two things a little separate. Okay, and one that's gotta be split up, so that you can see an example of that.